Good morning, everybody. What we're going to do is we're going to keep moving on with the trig identities. So that blue sheet that we have, we're just going to keep going with it. So really, what I need you to do is I need you to kind of have this thing ready because we're going to use it again. What we're going to do is we're going to prove things now. So what I mean by prove things is we are going to have an equal sign there. So what's going to happen now is the following. We're going to have these identities where we're going to state things, tangent of theta equals sine theta times secant theta. And basically what I need you to do is I need you to use those rules to prove that those two sides are in fact the same. So in this case, my recommendation, the way I would approach this is if you have something that's already kind of in its simplest term, like one trig function, start by leading it that way. So in this case, tangent theta is in a single trig function. So we're not going to change that. What we're going to do is see what we can do about trying to simplify this sine theta times secant theta. So again, first rule is, the first suggestion is to take a look at the Pythagorean identities and see if any of them work. Well, in this case, they don't because nothing's squared. So what that means is I'm going to go to the reciprocals and the quotients. And my suggestion is always put them in terms of sine and cosine. So that first guy is already in terms of sines and cosine. He is sine theta. And then what we do is we change secant theta, and secant theta is 1 over cosine theta. So now we put it in terms of sine and cosine. There's nothing to cross off. So what we're going to do is we're going to do that multiplication to bring it back together. Multiply across the top, sine theta times 1 gives me sine theta. 1 times cosine theta gives me cosine theta. And now I've simplified that or brought that together into one term. And I notice that sine theta over cosine theta, sine x over cosine x is tangent x. So this term is equal to tangent theta, which is equal to what we had at the beginning, this tangent theta. So we've proven that it's true. So that's an example of one that, that we could do, like, what we're doing is proving this statement is true. So for example, if I wanted to look at this one right here, secant squared theta, sine squared theta plus cosine squared theta over cosine squared theta. So if I'm going to look at this one again, this guy's already by himself as a trig function. So I'm going to leave it alone. What I'm going to do is kind of take a look and see if I can simplify anything over here. Well, what I would hope is after a certain period of time, you start to realize some of the Pythagorean identities that actually sine squared theta plus cosine squared theta is the same as 1. So what that says is that secant squared theta equals 1 over cosine squared theta. And now this identity should be there as well if we go ahead and look. So we use this one here, sine squared plus cosine squared equals 1. And now what we're going to do is we see we have 1 over cosine. So 1 over cosine squared is secant squared. So this term becomes secant squared theta equals secant squared theta. And again, we proved that it's right. So this is how I want you to approach them. Now, number 7 is going to be the first case where we got to do a little bit on both sides. The reason we got to do stuff on both sides is they're not in simplest terms. So what I need to do is I need to simplify the left, and now I need to simplify the right. So let's start with the left. What I'm going to do is I'm going to look and see, 1 minus cosine squared. That's one of my Pythagorean identities. I can rewrite this as tangent x over sine x. Sine squared x. And now what I'm going to do is I'm going to rewrite tangent in terms of sines and cosines. So sine x over cosine x over sine squared x. And just as a reminder, it's a fraction, so it's over 1. This is the same as multiplying by the reciprocal. So what this ends up becoming is sine x over cosine x times 1 over sine squared x. What we can actually do is we can cross off one of these with one of these, and this side ends up being 1 over cosine x sine x. So what ends up happening in this case, I've simplified this because there's really not much else I can do. So what I'm going to do on this side is I'm going to just rewrite. Well, secant x is the same as 1 over cosine x. Cosecant x is the same as 1 over sine x, We have two of them together. If I multiply those back together, I get 1 over cosine x times sine x. And in this case, I couldn't get it down to one term, but if you take a look, they're the same. So what we've done is we verified that trig identity. So it's very similar to what we did the last two classes. It's just all you're doing now is you're simplifying maybe both sides and comparing them. So really, again, this is just more practice with trig identity. So the answer key to this will be up on Schoology in our day 3 folder. This video, along with this video, so that you can kind of see the process on how this is done. So again, practice makes perfect on this one. I know it seems kind of trite to say that, but it really does. The more you do this, the more comfortable you become with the trig identities and which one to use when. You'll start to identify when you see things in a problem, which one you're going to use. So again, please use the optional reflection. Give me feedback if you have it. Otherwise, practice is what I need you to do. Thanks.